Hello, Paul. This video is just really going over a very basic model, but it does have a little bit of programming in it that the students did that I normally don't teach in the class. So it's a little bit more sophisticated than what we cover in class. At the same time, obviously, this can get much more complicated based on your needs. So simulate. There are some objects over here, some constructs that you can drag in and then double click on those to create process models. So flow models, inventory management, queuing systems, anything where they're running over time. And we have a little player up here at the top. I can rewind and start it. I can step through. And so this real basic system is an inventory system where we have daily demand that's variable, that hits every day. We have physical inventory, and we have a reorder point that triggers when we need to order more. So every day, what happens here is that demand hits the system, and over on this side, we have inventory, and if we have enough inventory, it's matched with demand and it leaves the system and we're done. But if we run out, we capture these back orders or these service interruptions. The other part of this is that I'm checking my inventory fairly frequently, almost continuously, but it doesn't have to be that way. And when the amount of inventory plus what is en route, what we've already ordered, if that total is less than the reorder point, then it triggers another order from the plant, and the plant then will send another truck. So the way this runs is when I rewind it, it's going to go and it grabs some material, some inputs. And really for this baby one, we're just really focusing on these these 6 inputs, where I put in what my daily average demand is, but it has variability around it. So there's a standard deviation. So every day I get something between 10 and 50 or so items on demand, just variable based on these parameters, normally distributed and then rounded to a whole number. When I place an order, the lead time right now is 7 days, but it also has variability, so the lead time can be higher or lower than this when I make an order. My reorder point, I control that. I set my trigger point. And again, this reorder point policy can be a lot of different policies. Right now, I'm just got a trigger point and then an order quantity, but we could have multiple batches. We can have at an order up to level. There's all kinds of different ways we can look at this. We can model the inventory infrequently, so maybe once a month we look at inventory. Maybe we have a policy in place that stuff is delivered to us on a regular basis every time. Anything that we want to model, but this one is a simple reorder point, order quantity, and then this tells me that I'm checking my inventory every day and then placing an order. There's no cost in this, but I could easily, since I know how often an order is sent, what my inventory costs are, my ordering cost, I could easily quantify the economic impact of these policies. These other things is that the model is getting more sophisticated. It's becoming a supply chain network where I've got a plant servicing a warehouse, serving multiple customers, but this model's not showing that. This is just a baby one I was just prepared. So when I run it, I'll run it really slow, but it's still going to run fast. When you run it, you look over here to the right, and this is running. So it's just run, right now it is run 94 days. And this is my inventory profile over time. And again, all I'm looking for is what the average inventory level, and then if I ever bottom out, if I actually ran out. So as long as I don't hit negative or go in zero, then I'm okay from a service standpoint. Again, it doesn't run really slow. It's hard to make it run real slow. But so all this is showing are the trucks en route. You can see the numbers are bouncing over time. And once it's done running, and I'm just running it a year, so I'm running it for 365 or so days. After it's run for a while, when it's done and it stops, what it does. So I ran it for 360 days. It generated, it sent over here the service level and the average inventory. And I can send any metrics I want from that. So the input output is an Excel interface. I could track that, and then within Simulate, I can do this. So I can certainly be silly and set my reorder point lower. I can set it at 250 and rerun this same thing. And what you're going to see is that my inventory starts bottoming out. I start having these service disruptions where I run out, and my service level, you can see, is not as good. And that just lets me play with the reorder point. And again, I know there's formulas out there, but more complicated systems, these parameters are harder to set. So this is not a facility layout, but it could be that way. We can model things moving around a warehouse floor. I'm just not on this particular example. It's an inventory management model is what we're doing. Okay, that should be enough. I mean, that's all I've got right now. I can certainly answer or prepare other demos if you're interested in maybe coming up with a Simulate project. Thanks.